Our next lesson is our introduction to our first four gas laws. And so the gas laws, what they are, they're a set of equations or formulas that help us predict how gases will behave. A couple of reminders, things you need to be very familiar with. Pressure. You're going to see pressures, volumes, temperatures, and moles in most of our gas laws. So pressure is going to be given a symbol capital P to represent pressure when we label our givens, and I do want you to label your givens. Now, possible units of pressure that we've just been introduced to on the last lesson could be atmospheres, torr, millimeters of mercury, pascals, or kilopascals. Temperature. For all of our gas laws, remember the kinetic molecular theory says that the average kinetic energy of the particles is directly proportional to the Kelvin temperature. So you always have to make sure you convert your temperature to Kelvin. If it's in Celsius, you got to convert it to Kelvin before plugging it into a gas law. That's extremely important to remember. Volume. So volume's possible units could be milliliters, liters, anything related to the liter, centimeters cubed, decimeters cubed. So if it's a volume unit, you should be able to recognize it because we've been dealing with those kind of conversions since chapter 2. Another abbreviation that you will see oftentimes used is the abbreviation STP. They really like to use this in gas law problems. And the STP, I'll capitalize here, is an acronym, if you will, for standard temperature and pressure. And when you see STP, it's a predefined set of conditions. It refers to 0 degrees Celsius and 1.00 atmospheres. Now remember, in all your gas laws, you have to convert your temperature to Kelvin, so you got to make sure you convert it to Kelvin, but it's defined as 0 degrees Celsius and 1 atmosphere. This is a definition, so therefore it has, that means therefore, unlimited sig figs in our problems that we do. So remember, definitions have unlimited sig figs. So let's look at the first four gas laws. These are sets of equations that help us to predict how gases will behave. Now, the first gas law is called Boyles Law. Boyles Law states that for a given mass of a gas, so if the mass is not changing, it's a given mass of the gas, at constant temperature, so the temperature is held constant here, the volume of the gas is inversely proportional to the pressure. So the way that we write that as in a formula is P1 times V1 equals P2 times V2. Pressure 1, the initial pressure and the initial volume, these are our initial conditions, is equal to the final pressure and the final volume. That is our first gas law, and it's known as Boyles Law. I remember that Boyles Law involves P's and V's, and please don't take offense to this, guys, but when I was in high school, this is how I remembered it. Boyles Law has the first three letters are boys, and when I was in high school, I thought all boys were perverts. So again, please don't take offense to that. That's just how I remember it. So you do need to be able to match up the gas law, name the scientist with the gas law. So the gas law that deals with pressures and volumes is Boyles Law. All right. Second gas law is Charles's Law. Charles's Law states that the volume of a fixed mass of gas, so again, the mass is fixed on Charles's Law as well. The mass is unchanging, constant mass, constant moles of gas. It is directly proportional to the Kelvin temperature if the pressure is kept constant. So in this gas law, pressure is unchanging, and what's changing is your temperature and your volume. So this is how we express Charles's law in a formula. Volume 1 divided by temperature 1, so V1 divided by T1 is equal to V2 divided by T2. This is our formula that we use for Charles's law. And again, I have to stress, these temperatures, when you plug them in to your gas law, they have to be in Kelvin. Celsius will never work. Your volume units always have to match. The temperatures have to match too, but they have to be in Kelvin. The next gas law is Gay-Lussac's law. Now, Gay-Lussac's law states that pressures of a gas are directly proportional to the Kelvin temperature again. So you're going to see temperature here, and it must be in Kelvin, if the volume is constant. So this gas law relates pressure to temperature. Gay-Lussac's law can be written P1 divided by T1 equals P2 divided by T2. The fourth gas law is the combined gas law. Now, if you memorize this one gas law, you will be able to derive Boyles, Charles's, and Gay-Lussac's from it. So this is really only one of the four that you need to memorize. And if you memorize this one, you kind of know the others. The combined gas law allows you to do calculations for situations in which only the amount of gas is constant. So you might have pressure, volume, and temperature all changing. So this is what that gas law looks like. P1 times V1 divided by T1 equals P2 times V2 divided by T2. Again, your temperatures still have to be in Kelvin. Pressures have to match, volume units have to match as well. Let me just point out to you here. If you read your problem and it tells you the temperature is constant, then drop the temperature out of the gas law formula and you've got just pressures and volume. So that's P1 times V1 equals P2 times V2, and that's Boyles Law. If you were to read your problem and it were to tell you that the volume was changing, the volume was constant, drop the volume out of your formula and that just leaves P's and T's. So you would get P1 divided by T1 equals P2 divided by T2. And this one is Gay-Lussac's law. And then if you read your problem and it tells you the pressure is constant, so drop your pressure out, and that leaves volume and temperature. So you would get V1 divided by T1 equals V2 divided by T2, and that's going to be Charles's law. So if you know this formula, you really know all four formulas. So memorize this formula, y'all. And we're going to work on using these formulas in some of our problems in our next lesson. All right.